Hi guys, welcome to Reignite Code. Thank you for joining us. Today we'll discuss one interesting problem, minimum speed to arrive on time. We can see these are the companies which asked this question in recent times. Without wasting time, let's dive into the problem statement. Here we are given a floating point number hour which represents the amount of time we have to reach the office. It is mentioned that to reach the office we have to take n trains in a sequential order, and it is also mentioned that each train can only depart at an integer hour. That means every train starts at 1 o'clock, 2 o'clock or 3 o'clock, like that, only integer hours. And if we reach any train like after 1.5 hours, we need to wait for half an hour more to take the next train. So finally they are asking us to return minimum speed that all trains must travel to reach the office on time. Let's take an example. In this we have three trains, train A, train B and train C. Train A covers 1 kilometer and train B covers 3 kilometers and train C covers 2 kilometers to reach the final destination. And now let's assume a speed of 2 kilometer per hour. So the time taken by train A would be distance by time. So 1 kilometer by 2, that is zero point 0.5 hours. Since we need to wait for zero point 0.5 hours more, we will add waiting time also. And for train B, it takes 1.5 hours. And since it is zero point 0.5, we need to wait for half an hour more. And for train C, it takes 1 hour and there is no waiting time here since it is not decimal. And so the total time taken will be train A plus train B plus train C. So 1 plus 2 plus 1, which is 4, and which is less than the mentioned time limit. So think in this way, if we reach in 4 hours with speed 2, then obviously if we take more speed we can reach more quickly. Since we need minimum speed, we can ignore speed greater than 2. And also let's assume one more case. If it is not possible with 2, we may have increased our speed and ignored all the speeds which are less than 2. So here is our intuition comes to apply binary search on speed. Okay. And for the same example, let's decrease speed by one more. So now our speed is 1 kilometer per hour. Then train A takes 1 hour and train B takes 3 hours and train C takes 2 hours. So the total time will be 6 hours, which is the exact mentioned time. So the minimum possible speed would be 1 only for this. So the answer is 1. And let's take one more different example. So in this case, the mentioned time limit was 2.7 hours. And let's suppose our speed will be 3 kilometer per hour. Then train A takes 0.333 hours and train B takes 1 hour and train C takes 0.66 hours. And since we need to wait at least for integer hour, so we are considering the waiting time also. So in this case, the total time will be 1 plus 1 plus 1, 3 hours, which is greater than the mentioned time limit. So, but the answer was 3 only. So here our mistake was considering waiting time for last train. We should not consider waiting time for last train because there is no next train to take and therefore no waiting time. So the answer will be 1 plus 1 and this will be, sorry, this will be 0.6667. So the total time taken will be 2.6667 hours, which is less than the mentioned time limit. So the answer will be 3 in this case. And let's take one more different example. And in this case, the time limit was 1.9 hours. At the best case, train A would take minimum 1 hour to reach train B, and train B takes one minimum 1 hour, and then only we can take train C. So in the best case we have 2 hours already completed, but the specified time limit was 1.9 hours, which is impossible to complete. So therefore our answer is -1. Let's dive into the code. So we will use binary search approach. Here I am taking low as 1 and high as 1 plus 7 1 because they mentioned maximum speed would be 10 power 7 only. So I'm taking one more extra for impossible case. So every time we'll take the mid pointer, and if the mid is equal to low, we'll break and we'll write a check function to check if our mid satisfies the given time limit or not. If it is satisfied, it will return true and we'll update the high pointer, and if it is not satisfied, we'll update the low pointer. So let's check the check function. So in this will be the total time with our current speed, and this is a variable to store the time until the last one. And we are iterating over the array, and to consider the waiting time also we are using seal. So we can calculate seal by using this formula, or you can directly use seal function. So I'm using this formula, distance of I plus s minus 1 by speed. And also you can observe here we are not considering the last element. For last element we will add separately. So the total time will be this one. And if it is less than the time limit, then we will return true, or else we will return false. If our high pointer is still at the same position, that means it is impossible to get the minimum speed. So we'll return -1, and else our answer is stored in high pointer, so we'll return high. So coming to the time complexity, we are using binary search, so the login, and we are iterating every time entire array, so the time complexity will be n into login, and we are not using any space, so the space complexity would be O of 1. Thank you.